Yes, let's look at the equilibrium that involves phosphorus, chlorine, and phosphorus pentachloride or phosphorus 5 chloride. And we see how you can overcome the problems of the questions that are examined under this area. So we have our first example here, and it is reading 83.4 grams of phosphorus 5 chloride were placed in a vessel of 9.23 decimeters cubed. When they say this mass was placed in this vessel, 9.23 decimeters cubed, it means that after getting the moles, those moles will be for this. But remember, we'll be looking for moles in a decimeter cubed or in 1,000. So we shall be dividing by 9.23 to get moles per decimeter cubed. Right. So they're saying that at equilibrium, 11.1 grams of chlorine were formed at a total pressure of 250 kilopascals. So they want us to calculate the number of moles of phosphorus 5 chloride, phosphorus 3 chloride, and chlorine in a vessel at equilibrium. What do we start with? Because we are given masses, we need to get number of moles. So we need the molar mass of phosphorus 5 chloride. Phosphorus weighs 31 plus chlorine 35.5 times 5. The whole of this will give you 208. That is the molar mass. It means now here I can get moles of phosphorus 5 chloride. Moles are equal to the mass, which was given as 83.4, divided by the molar mass, which is 208. And this one gives 0.401 moles. Then, still we are given mass of chlorine at this pressure. So mass of chlorine, molar mass, sorry, will be, let's use 35.4. Will be 35.4 times 2. And this gives the molar mass of chlorine as 70.8 grams. So here we can get moles of chlorine. Moles of chlorine are equal to the mass of chlorine, which is 11.1, divided by the molar mass, which is 70.8. This gives you the value of moles as 0.15678 moles. Now we've gotten moles of phosphorus 5 chloride and moles of chlorine. But these moles of chlorine are moles at equilibrium. So if we write the equation, the equation will be phosphorus 5 chloride. It is a gas and it will be dissociating from phosphorus 3 chloride gas, then plus chlorine gas. So in this case, we have the initial moles. Initial moles of phosphorus 5 chloride that were heated were 0.401, and initially we don't have moles of phosphorus 3. At the same time, we don't have the moles of chlorine. So here we can get moles dissociated or formed. This will be, since this is dissociating, to be 0.401 alpha. And because the mole ratio is 1 to 1 to 1, also these ones are going to be the same. Even this. Now, but remember, moles of chlorine at equilibrium, we've already gotten them. So if these are moles of chlorine at equilibrium, And we've already gotten the moles of chlorine also at equilibrium. So we can equate them so that we get the value of alpha. So in this case, but moles of chlorine at equilibrium 0.401 alpha is equals to the moles we got 0.15678. So you divide by 0.401 and get you alpha as 0.391. So after getting the value of alpha, now we can, I forgot to get moles at equilibrium. Moles at equilibrium here, it will be 0.401 minus 0.401 alpha. This one will keep the same, 0.401 alpha, because even if you subtract 0.401 alpha. So alpha is that. So now I can get moles of everything at equilibrium. So moles of PCl5 at equilibrium will be 0.401 minus 0.401 times alpha, which is 0.391. And this gives you 0.24421 moles. Then I also get moles of phosphorus trichloride or phosphorus 3 chloride. Moles of PCl3 at equilibrium will be equaling to 0.401 times the value of alpha, 0.391. And this will give you the moles of PCl3 as 0.156. 79 moles. Then finally, can get moles of chlorine at equilibrium. Moles of chlorine at equilibrium would also be 0.401 times the value of alpha, 0.391. And this will read 0.15679. So after getting the moles at equilibrium, the question wants us to get the value of Kc for the reaction. So the value of Kc is equals to the concentration of PCl3 raised to the power 1 times the concentration of chlorine raised to the power 1 over the concentration of PCl5 raised to the power 1. But these moles are in 9.23 decimeters, but we need in a decimeter. So the concentration of PCl3 will be equaling to the concentration of the moles of PCl3, that is 0.15679. We divide by 9.23 decimeters cubed. So this one will give us 0.0170 moles per decimeter cubed. Then also, concentration of chlorine is the same, they are the same. So it is 0.0170 moles per decimeter cubed. Then concentration of PCl5 would be equal to moles of PCl5, that is 0.24421 over 9.23. So it will give us the value as 0.0265 moles per decimeter cubed. So if we substitute here to get the value of Kc, our Kc is going to be equal to 0.0170 times 0.0170 divided by the one of PCl5, which is 0.0265. Yeah, so this is going to give us, remember everything is moles per decimeter cubed. So here it will be moles per decimeter cubed, everything is square, then this is moles per decimeter cubed. So when this one moves up, we shall get the value as 0.011 moles per decimeter cubed. Because one of the units will cancel here, so we shall remain with it, only that. Then to get the value of Kp, it means we need to first get the total moles at equilibrium, then we get the partial pressure of each component, then we substitute in the formula for Kp. Now, total moles at equilibrium, we shall add the moles of every component, 24421 plus 0.15679 plus 0.15679. So these are the moles I had gotten for each component at equilibrium, and the total comes to 0.55779. So after getting these moles, I can get the partial pressure of each component, beginning with the partial pressure of PCl5. It will be moles of PCl5, which is 0.24421 over total moles 0.55779 times the total partial pressure 250. This one will give you the partial pressure of phosphorus 5 chloride as 109.45 kilopascals. That is one. Then can also, as we get the partial pressure of phosphorus trichloride, it's going to be equal to vapor pressure, moles of PCl3 15679 over total moles 0.55779 times total 250. So this will give you 70.27 kilopascals. Then partial pressure of chlorine. Partial pressure of chlorine is equal to moles of chlorine, that is 0.15679 over total 0.55779 times total 250. So this is going to be equal to 70.27 kilopascals. But Kp, expression for Kp, sometimes they first tell you to first write those expressions, but in case they haven't, you have to write it at the right time. So Kp is equal to the partial pressure of phosphorus 5 chloride, phosphorus 3 chloride, raised to the power 1, of course, times phosphorus of chlorine raised to the power 1 over phosphorus of partial pressure of phosphorus 5 chloride. Then you substitute. So it is going to be 70.27 times 70.27, everything divided by 109.45. And you get your value of Kp as 45.13 kilopascals. Yeah, so that is how you would be expected to do this question. Yeah, let me do you another example and we see. Another example would be 2.085 grams of phosphorus 5 chloride was heated or were heated in a 1 liter vessel until equilibrium was attained. Until equilibrium was attained, full stop. Then the vessel was broken under excess potassium iodide solution. Excess potassium iodide solution. Then the iodine liberated required required 40 cubic centimeters of 0.1 molar sodium thiosulfate solution. Calculate the equilibrium constant Kc for the reaction. Yeah, so that is what we are expected of calculating. Now you need to know the reason as to why the vessel is broken under excess potassium iodide solution. And why is it rapidly broken? Okay, we rapidly break it, stop the reaction and fix equilibrium, so that it does not adjust itself to the equilibrium value at lower temperatures, I always say. But then we break it under potassium iodide to dissolve and oxidize chlorine present to chloride ions, and the potassium iodide is reduced to iodine, right? So in other words, now when we are given all this, smartness matters a lot. Since we are given mass of phosphorus 5 chloride is the one which was heated, so we can get moles which were heated by first getting the molar mass of phosphorus 5 chloride. Molar mass of PCl5. Phosphorus is 31 plus 5 times 35.4. So the molar mass is 208 grams. So this can give us the number of moles. Will be equaling to mass, that is 2.085, over the molar mass, which is 208. So we shall get the number of moles as 0.01 moles. Now after getting those moles, right, these are moles before equilibrium. Then we can as well get the moles of sodium thiosulfate or moles of thiosulfate ions that reacted with the iodine. So moles of thiosulfate ions that reacted with iodine, or you can write the whole thing, sodium thiosulfate, will be equaling to they will be equaling to 40 times 0.1 out of 1,000. Because these moles given are in 1,000. So you'd be saying 1,000 cubic centimeters containing 0.1 moles. What about 40? So this one will give us the number of moles as 0.004 moles. After getting moles of thiosulfate ions, by writing the equation for the reaction between iodine solution and thiosulfate ions to form tetrathionate and iodide ions. We can get moles of iodine. Here we can get moles of iodine. So moles of iodine will be a half of 0.04. Half of 0.004 moles. So this will give us 0.002 moles. So these are moles of iodine that we formed. Then another thing, actually these moles of iodine were formed from potassium iodide. All right. Then now, again from chlorine, okay, gas plus iodide ions to form iodine aqueous plus 2Cl minus. You can see that 1 mole of iodine is formed from 1 mole of chlorine. So you can get moles of chlorine, okay? It means that also moles of chlorine are going to be equal to 0.002 moles. But these are moles of chlorine at equilibrium. Why? Because 1 mole of iodine is formed from 1 mole of chlorine. But you need to know still the reason as to why we break the glass under potassium iodide to dissolve and oxidize the chlorine to chloride ions, as potassium iodide is reduced to iodine. As simple as that. So now here, after getting moles of chlorine at equilibrium, yeah, we can now battle the calculation. So we have PCl5 gas so here we need the initial moles. Initial moles of phosphorus 0. Initially, because they told us that 2.085 were heated in a 1 liter vessel. So initially, we are having, should we call it 1 mole? Yeah. Because now, yeah, if initially we have 1 mole of phosphorus from stoichiometry, here 0, here 0. All right. Actually, our initial moles of phosphorus is 0.01. The ones we got from the molar mass, so 0.01. Then moles dissociated or formed Since moles of iodine formed are 0.02, and we've seen that also moles of chlorine are 0.02, then throughout, because of mole ratio, all of them are the same. So at equilibrium, we get equilibrium moles, it will be 0.01 and 0.002, 0.002, 0.002. So this one can enable us get everything that we need. So here, and get moles, you have moles, you have moles. But since it was in 1 liter, so what we shall get, we shall retain those moles, and then we substitute in the expression of Kc. I want everyone to complete that, and I see what we have obtained. I'm doing for you the last question, then I give you like more or two for you to do. I'm doing for you the last one, and 3.6 moles of phosphorus 5 chloride were allowed to attain equilibrium at 200 degrees Celsius in 1 decimeter tubed vessel. If the equilibrium constant of the reaction, the equilibrium constant of the reaction is 0.08 moles per decimeter cubed at 200 degrees Celsius. Calculate the percentage dissociation of phosphorus pentachloride at equilibrium. Let me change here so that it becomes very easy for us to interpret, or it becomes logical for us to interpret. 2.00 grams, not moles. When you see grams, means you have to first convert them to moles by yourself. So we have been seeing that the molar mass of phosphorus pentachloride, you have to show us the working. But let me quote it, 208 grams. So moles of PCl5 before equilibrium is going to be 2.00 over 208, which is 009615. So if we write the equation, it will be PCl5 plus chlorine. Initial moles, or initially, we have moles as 0.009615, and there we don't have any moles Yeah, moles dissociated or formed. Write all the words: dissociated or formed moles. Multiply alpha, so it's going to be 0.00961 alpha. Since the reaction ratio is the same, even here, so looking at all this, remember volume is 1 liter. But you can get moles at equilibrium. Equilibrium moles will be, this is common because it is this time subtracted. This subtract this is going to be 0.009615 into 1 minus alpha. Then this is the same. And after getting this, since it was in 1 liter and these are equilibrium moles, it means that these are the same as the concentrations. So Kc was given, but it is always equal to concentration of PCl3 times concentration of Cl2 out of concentration of PCl5. So you can substitute everything. It means that Kc 0.008 is equal to concentration of PCl3, which is since they are the same, we can square them. So it is 0.009615 alpha squared over PCl5, which is 0.009615, 1 minus alpha. I'm going to task all viewers to make sure that we come up with a simplified equation as 9.244 alpha squared plus 7.6, which is 9.62 alpha, then plus, I can say minus 7.962 is equal to 0. Here, you can put in the bulldozer formula. So our alpha will be equaling to minus b. So it is going to be negative 7.962 plus or minus, because all of this is a, b, c, plus or minus b squared, which is 7.962 squared minus 4 times a times c, negative 7.962, everything over 2a. So we're going to get the value of alpha as negative. Here you can put on the calculator after showing us the substitution, 1454 or 592. But the value of alpha cannot be negative. So we shall discard alpha is equal to negative 1.454, implying that our alpha is 0.592, and they want the percentage. So the percentage dissociation will be equaling to 0.592 times 100, which is going to be 59.2%. So I'm giving you 2 numbers for you to practice, and you see how much you have understood. Our so supposed to be number 4, 3.6 moles of phosphorus 5 chloride in a vessel of volume 2 liters was found to be 38% dissociated. Calculate the equilibrium constant case for the reaction. If I'm to give you a hint, a simple hint I can give you is that when they say it is 38% dissociated, this one is giving us alpha, 38 out of 100. Number two, when they say the volume was found to, rather in a volume of 2 liters, it means that to get moles per liter, we shall be dividing by 2. And generally the answer should be 0.419 moles per decimeter cubed. Then number 5, calculate the percentage of chlorine in the equilibrium mixture formed when 0.4 moles of phosphorus 5 chloride were heated in a 1 liter vessel and they gave equilibrium constant as 0.02 moles per decimeter cubed. You should calculate and be able to obtain your answer as 16.67%. Till next time, we are remaining with one more lesson to finish this topic called chemical equilibria. Till next time, see you.